Viktoria. I'm presenting our work on multi-modal registration. Multi-modal registration is finding the relative pose of images of different modalities to each other. We have ultrasound sweeps, MR volumes, and their relative pose to each other, the registration. It is an essential task for many procedures, especially the ultrasound-guided interventions, as we can see, for example, many things on a high-resolution MR. However, we can do ultrasound in real time. It's generally a hard problem, and most solutions need a close initial pose. So clinicians are forced to mark correspondences before the procedure. Our method works with arbitrary start poses. It utilizes key point descriptors. This is a computer vision concept that classically has been handcrafted. The idea is we find key points, regions in an image that we have a high chance of recognizing from a different angle, under different conditions. We find these correspondences into different images, and then with this, we can find registration. So these key points are generally described with a key point descriptor. This is basically a vector that shows us what are the characteristics of these key points. Modern approaches have utilized deep learning for this, and there are different approaches. First, detect the key points, then describe them, or do this simultaneously. We built upon such a work and adapted to the medical domain. This is our proposed method. So we have an ultrasound frame, that's 2D image, and an MR volume. For each of the modalities, we have a network that learns the descriptors on a coarse grid. So for each pixel or a region of pixels, we have a descriptor. These two are then joined together in a differentiable matching layer that computes the similarity between each pixel and each voxel. This is done by the dot product. After a double softmax, we basically have the likelihood that a pixel and a voxel correspond to each other. We threshold this and have the correspondences, and then after utilizing a classical algorithm, for example, Ransack, we have the rigid pose. This method is generic in the sense that it works with different frames, different modalities. Our example and our experiments have been on ultrasound and MR. It's multimodal, as you can see. Multidimensional, this is a 2D frame, this is a 3D volume. No correspondences have been labeled, and it's initial pose independent. It's also quite interpretable because we can visualize very well this matching layer. As said, we have for each pixel and voxel the similarity. So I can choose a pixel on the ultrasound frame and visualize the similarity to every voxel on the MR. So here I have chosen this pixel, and this MR match basically shows me where would be the correspondence according to the networks. Most importantly, I have this colorful cloud here that is a heat map of all the similarity. We also have it here visualized on the multiplanar views of the MRs. So I could choose any point here, for example, the vessel, the skin, or the liver outline, and I would see how the networks perform on this specific region. Our experiments have been against the baseline method, that's registration from segmentation, and we also see if we fall in the capture range for an established iterative optimization algorithm. Because, as said, there are such algorithms that are quite good in finding registration, but need a close initialization. So one could use a method that does not require this and then refine. And these are important experiments to be done. For more information, you can come to the poster session Tuesday at 5. I would love to see you there.